We're going to start out this screencast on polymorphism by creating a new project. We're going to use the command line app template, and we're going to use a shorthand writing here just to get started quickly. Alright, so first up, what we're going to do is we're going to create a couple of classes. So we're going to create a shape class, we're going to create a circle class, and we're going to create a star class, like so. Within the shape class, what we're going to do is we're going to create a single method, public void draw, and inside of this method we're going to write a system.println statement in which we write shape cannot be drawn. Now this maps back to the discussion of abstract concepts. So whenever we're told to draw a shape, what we will do is we'll end up deciding on a particular shape that we are going to draw, and then we're going to draw it on a paper, if that's what we're doing. So a shape in of itself cannot be drawn, but any concrete shape of course can be drawn. So shape here, we're going to state that it cannot be drawn, and then instead we're going to use inheritance to ensure that we indeed have some shapes that we can draw. So we're going to let circle extend on shape, and we're going to override the draw method. And inside of here, of course, what we need to do is we need to draw a shape. So let's draw a shape the fastest way possible. And the shape that we're drawing here is a circle. So arguably here, we're drawing a circle. Of course, you could question as to whether this is a very sophisticated way of drawing a circle, but nonetheless, it's fast. So let's transition into star and do something similar over here. So we'll let star extends shape, and then we're going to override the public void draw method, and then define the behavior within the star class, like so. System.println, and then in here we're going to put a star. So now we have two shapes that we are able to draw, and we have the shape class, which in itself we cannot draw. I mean objects of it, of course. So let's try and go ahead and create some objects over here. The first object that we're going to create is a shape. So we're going to actually let's call this shape. So we create a shape object. We're going to create a circle object. We're going to create a star object. Now, of course, what I can do now is on each of my variables, I can go ahead and call the draw method to invoke the draw method on the objects that I've created. So let's just do that and see what happens when we're running the program. And here we see that we've created the output that we expected. So from our shape object, we see that shape cannot be drawn. Of course, that is because in our shape class, the draw method states shape cannot be drawn. For the circle object, we're drawing a circle down here, and of course this is because we overridden the draw method in our circle class to draw a circle. And then the same of course applies to the star class, where we overridden the draw method as well, and we are drawing a star. Up until now, everything we talked about in this video has to do with inheritance and overriding methods. Now, polymorphism means that something can take on many forms. And this also applies in object-oriented programming. So for instance, what we can do is we can say that a variable of a certain type is able to point towards or reference objects of that types and any subtypes of it. This means that a variable of type shape can refer to shape objects, but it can also refer to any objects of classes that inherit from shape. This is circle and star in the case of this application. This means that I'm completely allowed to do the following. I can say that my variable of type shape, that we call shape, can point towards a circle object. Now if we just change this back, of course this also means that on the left hand side here, I can change the type of my circle variable to shape, and I can change the type of my star variable to shape. And if we run this program, we will see that nothing has changed so far. So the same behavior as before applies, and here we observe a special phenomenon. Because of course, if we look over here on the left hand side, the type is shape in all circumstances. But we see that the output of the program has not changed, which means that it has to be so that the draw method in shape is not the one being called in all cases, because we see that indeed the draw method in circle and the draw method in star is called. We call that dynamic binding. And in short, dynamic binding means that it is the actual object. So this is what we are creating here on the right hand side. It's the actual object that decides which methods we are invoking. So of course, if we have a circle object over here, ultimately the draw method on the circle object is the one being invoked regardless of the type here on the left hand side. Seeing as we can use the same type for all these different kinds of objects, how can we utilize this to do something intelligent with it? Because down here, really what we see is the same program, it fills the same amount of lines and so on. What we could have done instead though, knowing that the concept of polymorphism exists, is that we could have created a shape array, and we could call that shapes, and we could create a new shape array of size 3. Now, instead of creating these 3 variables down here, what we could do is we could say shapes and then index 0 equals this shape object. Shapes index 1 equals this object here, and shapes index 2 equals the star object here. So now I have an array containing three different types of shapes. And now what I can do is I can create a for loop. And in this for loop, what we're going to do is we're going to declare a variable I. And we're going to let that variable start from 0. We're going to state that I is less than shapes.length. And we are going to, in the update part of the loop, we're going to add to our variable I. And so down here, of course, we are doing our brackets, and within the brackets, what we're going to do is we're going to say shapes and then add index I dot draw, like so. Now if we execute this code, what we will see is we'll get the same program output as before, but now instead of separately invoking the method on each of our objects, what we are doing is we're using a loop to achieve the same functionality. So we will let the loop through the array of shapes and call draw on each of the objects in that array. So that's pretty neat, because this means of course that if we had a shape array containing 100 shape objects, we wouldn't have to write 100 lines of code to invoke draw on each of these objects. We could merely use this loop here to loop through all of the objects and call draw on them.